Good morning, everyone. My name is Christina, and we are pleased to welcome you to the Washington Labs Academy webinar series. We hope you find the next hour so useful and informative. We've developed our webinar series to deal with some of the technical and administrative issues our customers face on a day-to-day basis. We recognize engineering challenges can be complex, and we're always looking for ways to support the technology industry. Before we begin, I'm going to go over a few housekeeping details. First of all, I hope everyone is able to see the title slide on their computer. This presentation is part of our webinar series presented this calendar year. We've muted everyone's microphone to keep the meeting quality as high as possible. A recording of the presentation is underway and will be sent to all attendees, and a training certificate is sent to attendees of the live presentation. A full screen view may be preferred. In the menu on your screen, go to View and then select Full Screen. Use the Escape key to return to normal view. We encourage questions during the presentation. You can submit a question by enabling the chat icon at the top or side of your screen and typing your question to the host. We will go through questions at the end of the presentation as time permits. We'd love to hear from you. You can contact us via phone or email. Please reach out to academy@wll.com or to the presenter directly. And now I'd like to introduce our speaker, Stephen Ferguson, Executive Vice President, Washington Laboratories Limited. Steve has over 40 years experience in testing system and device evaluation. He has instructed in the area of test methods for the past 15, focusing on electromagnetic compatibility, product safety, and environmental test methods. His comprehensive knowledge on MIL Standard 461, MIL Standard 810, MIL Standard 704, 1275, 1399, and CE marking requirements supports test and evaluation for military, commercial, and industrial equipment. So without further ado, I'm going to go ahead and hand over the presentation to Steve.
Thank you, Christina. A few words. Bon pomeriggio. Guten Nachmittag. Bon après-midi. Bon dia. And good morning. I've butchered 4 languages. I appreciate your attendance. How's my sound, Christina? Is everything okay?
That's loud and clear.
Thank you. Welcome to Commercial Wireless Compliance. This is the final session, 8, that deals with risk management. This has been a well-attended series with lots of speakers from various locations dealing with FCC, the Radio Equipment Directive, and Anatomy of a Test was a very good presentation by our own John Rapella. Wireless immunity, and several topics. So if you've missed these events, they've been quite informative. You may want to consider obtaining recordings, especially, well, if you registered for the event, you would automatically get the recordings, but the recordings are available if you decide you would like to see some of these. Our website has the information regarding availability. As I indicated, this is Session 8, Risk Management, the 8th of the 8-part series. The sessions have been presented on a weekly basis with each session about 1 hour. As I indicated, the recordings are available. Christina, I need you to do something, and I hate to do this, but this presentation must have been pulled up before I finalized this morning. I made minor changes. I see this one has question marks. Could you load the appropriate slide?
Oh, sure, absolutely.
Or can I do that since I have the ball?
Well, you could do that since you have the ball. That's okay.
Oh, okay. Let me, I want to get rid of this. How do I do that? Just get rid of, I'll just share a file. I'm going to go get this thing. I apologize for this. Christina, you got ahead of my final edits. I should have let you know that. So bear with me while I go after this thing. As soon as I saw those question marks, I realized it was incomplete. Okay, that's better. I apologize, Christina, for not letting you know that.
That's okay. Here we are.
Okay, we're going to go over a few things here as the outline indicates, understanding the requirements and some risk elements we need to deal with. I need to touch on applying standards because that sometimes gets a risk review kind of awkward, shall we say. And basically the process, and I'm going to deal with the subjects of documentation a little bit. Risk. Well, it's a possibility of, according to Merriam-Webster, I believe, of possibility of loss or injury, and that someone or something creates a hazard. It's an element that you say, I do not want to do this, as in throwing the dice is a risk that you will lose whatever you have gambled. It suggests that risk may be acceptable, and we take those risks every day. Some standards support it, and others do not. For instance, the medical standard supports a quantitative acceptance. So the manufacturer can decide, well, if the risk is low or virtually non-existent, I'm going to go ahead and produce that product and believe that the user will not do this. Safety standards promotes the identification and mitigation mode. And the radio equipment directive, the wireless thing that we're kind of focusing on, includes risk management requirements, but is kind of silent on whether it's a quantitative or a mitigation type approach. The reviewers I've spoke with and the radio equipment people that have discussed it indicate mitigation, that it's not acceptable to have a risk that you did not resolve. Now, we know that that's not absolutely pure and it never will be, but once we identify a risk, the standards indicate you need to evaluate to determine if the risk is really present or not, and analyze it to say, if this happens, then what is my risk, and will it prevent the, quote, harm or injury, shall we say. So we look at this, that we got two different things. This quantitative thing that the medical looks at, and the mitigation method that the safety or the RED takes that. And by the way, I apologize for my typo. The Radio Equipment Directive is not right. It's the RE directive or the RED, whichever way you want to go. The medical devices that have radios, and they're everywhere. We know radios are our future. The Internet of Things is showing that every day, that and wireless inquiries are clearly there. So the radio systems, the wireless sensors, the wireless whatever, is a true element throughout. And we see this in our world of medical devices today, where especially those sensitive signals like an EKG, etc., use the wireless device to avoid the cable coupling from a radio. The wires can pick up medium frequency emissions and overpower the low-level signals, these little sensors that go on our body. So they're being replaced with RFID kind of things, where the medical device interrogates and gets a reply with a digital type signal, and the cable coupling from some of the other radios tends to take that away. So what do we do here with a medical device with a radio? Well, you got to deal with the quantitative things associated with medical, and you must mitigate if it's the radio issue. So you can have a dual risk evaluation associated with this kind of device. It's virtually impossible to integrate a medical risk analysis because of quantitative resolution and the ISO 14971 guide requirements. You can't really use that kind of thing with a radio or the must mitigate. Now, clearly, can we put those in the same form? We certainly can, but we're going to have some evaluation things that are obscure, to say the least. So dealing with it, it's an issue. What does the RED require? Well, in the requirements area of the directive itself, you'll see there are several clauses, 10, 20, 32, 40, 60, etc. Dealing with functions of risk. You need to protect against the risk of harmful interference. You need to deal with evaluation of risk for non-implementation of essential requirements. And this applies to selected radio categories. Importers need to restrict the risk of the market if the device presents a risk. So we have several things. And Decision 768-2008 EC is invoked regarding conformity assessment with a risk evaluation. There are several clauses in here that's present. Also, Directive 676-2002 EC provides for the conditions in limiting the quantity of items to limit the risk. So there are certain directives that say, well, you can only have so many of these in any particular area because of the potential for interference from each other, collocations, things of that nature. So the limitations may be presented for certain selected things. And remember, there are several procedures for measures to be taken if the risk to health or safety is presented. So there are several rules here, and the exact details of each I kind of summarize here. So you'll need to look at the directive to take care of that. And truly, what is a risk goal? It provides an understanding that risks have been evaluated for several things. Harmful interference, like the use of the radio spectrum, interoperability, these functional things. And we'll go over a few more as this goes forward. And implementation of the essential requirements. Did we put into this thing what we said we'd put into this thing? Again, we'll touch on a few examples as we go through. And obviously the health and safety to persons, domestic animals, and property. And domestic animals is stated here. A lot of standards kind of it's not stated well. So people try to avoid the fact that in our world of compliance, we treat domestic animals as a person. If you have your cows that produce milk for the family, that's a domestic animal that needs to be accorded protection. They should not be exposed. And the rules apply to these. So we can't arbitrarily put a radiating antenna and put a sign up that says you need to stay away from here, and we forget that the domestic animals did not read the signs. So we need to prevent that activity. Also, property damage. If this radio causes my property to not function as it should, that comes into place here. It invokes the low voltage directive without regard to the voltage. So we treat the item as a device that no matter what the voltage were, the low voltage says you need 50 volts DC or 75 volt AC to be evaluated per the low voltage directive. This implies any voltage. Now, that presents a lot of potential issues if I'm a self-contained battery-powered device, and so I don't have any of that. So dealing with that is a little bit cumbersome for the laboratory and whoever's doing the evaluation, because what do you leave out? Do things still get evaluated? Well, absolutely, but then if there's no requirement for that particular voltage, it gets treated as a not applicable kind of an issue. Electromagnetic compatibility is also one of these health and safety items, an adequate thing of electromagnetics, and it calls out these particular requirements. The documentation identified in Module B.3.C states that the technical documentation shall make it possible to assess the radio equipment's conformance with the applicable requirements with the directive and shall include an adequate analysis and assessment of the risks. So obviously I didn't spell check here. So the statement's kind of obvious, the shall. The documentation has got to take care of this thing. And so assessing the conformance is kind of a deal here. So how do we get to do this? What standard do we use for the evaluation? Well, the risk assessment is conducted according to what? it isn't stated. So the risk assessment you see in this examples here may not conform to anything. However, ISO 31010 has a general risk assessment evaluation. If you want to encounter, shall we say, less questions regarding how you've evaluated it, citing this standard, if you use it, may be inappropriate. So what do? Well, we've got to prepare the analysis. Number one, identify the requirement. If we don't know what a requirement is that could affect harmful interference, health and safety, or etc., then we've got a hole right there. All the requirements need to be identified. Now, the list in the standard kind of points to those areas of risk. Not the directive, but the applicable standard for the radio. And it deals with evaluation of certain things. Well, if we're evaluating it, there's typically a risk associated with that evaluation criteria. So stepping away from any of those as part of your risk evaluation tends to present a hole to a reviewer, approval authority, etc., regarding what you've done here. Document the control measures. What did I do to control that particular risk? Did I use a filter? Did I limit the power? Did I do what? And document the method of assessment. How do you know you got it right? Sometimes that's nothing more than the conformity test using the standard test methods in the applicable radio standard. And you need to provide some sort of compliant results statement. Did it pass? Is it compliant? Did it meet the requirements? Did it do what? And don't forget, you need to deal with each of the essential requirements. Decision 768/2008, there's a module regarding some guidance on what things are applied, developing a procedure for the evaluation. But remember, these requirements are stated. There is, and I'll go over it, there's essential requirements listed in the directive. There's also, that feeds into the requirements associated with the standard evaluation. And also remember that part of this, quote, risk-based standard is that technology is advancing far faster than standards. So if new technology is derived that you are implementing that's not covered by the standard adequately, you need to incorporate it in your list, and that could involve even more in developing how do you assess it. And since obviously if you're in this technology realm, you're not within the harmonized standards, so it's indicated you will need to use a notified body to obtain your compliance, shall we say, or your approval. So you're going to be explaining that to them. So that may take on some additional justification and support. Dealing with these advances is always a kind of a tricky situation. So this how situation, I got a couple of minor examples here for like a safety protection. I'm going to use a control measure, a resettable fuse in the battery discharge. If the battery current, it's a limit current. So if we're there and the issue says that the fuse stops the current from going excessive and causing fire, the battery into rapid disassembly, the torch out of the battery because it gets into the short circuit and delivers a lot of current because nothing stops it. So I may have a thermal fuse into here and evaluate that per the IEC standard. Is that IEC standard appropriate? Well, if that's what we're using, then I'm going to say that's how I got there and found it to be compliant, that it actually did limit the current, it opened up and took care of it. And that requirement would be safety protection. You could go into detail on that risk element as to electrical, dealing with several different things. The safety protection, the radiated emissions, power limits exposure. It's dealing with a permissible exposure. And I proved that through an MPE evaluation. Why did I mess these slides up? It's evaluated per the ISO for the RF exposure associated with the device. And if it complies, then that particular element of exposure tends to meet the requirements. Remember that this power may be different in the standard for a fixed device, a portable device, and a mobile device. So those three categories may affect how you have to deal with this. Harmful interference, that the oscillator remains stable over the operating temperature range, operating frequency range. And this is a dealing with it's there, and it's the frequency stays stable over the temperature range is what I was looking at. The temperature range may be extended quite a bit, and the evaluation in some standards require you to validate that at various frequencies or temperatures throughout the thing and remain that the RF stays stable. So harmful interference, if the oscillator drifts into the adjacent channel or just goes off frequency, is a harmful interference thing that should not be permitted. Production things, establish a quality assurance sampling program for the test laboratory. It might be an in-house test lab or whatever, and you're saying that you're dealing with this on a 0.3% basis of the sample rate for your production. Many ways of evaluating this risk, and that the design is in fact stable and that production remains stable is a sampling program that's there. And how deep you delve into the safety protection issues. A reviewer, a notified body reviewer A, may look at it and say, well, you comply with the, quote, safety standard, and that's all they want to hear. Another one may say, I want to see the details associated with the safety report needs to be in the file. Well, obviously, your file needs all these reports. So it's clearly something you need to produce. And did the safety evaluation cover your particular issue? That you have a battery, and and somehow the test laboratory didn't realize that you had a backup battery system, and they put in their column of batteries none, then they're going to have a gap because the reviewer says, you got a battery, and the safety lab says it doesn't exist. So that's a discontinuity that you need to consider. And that's not your risk. That's something you use to mitigate risk. So it's got to cover it. And the reviewers are kind of particular about that. Now, they may look at it and say, well, the laboratory is accredited, and not look at it closely. You need to look at it. If they've not covered what your device is, you need to get that fixed real promptly, because you'll have a long-term effect on this thing. As I mentioned, this Directive 768-2008 EC establishes several modules for conformity assessment procedures. In the Annex 2, they even describe it as conformity assessing, with 8 modules there to provide various conformity approaches based on internal production, EC type examination, and you can read these things depending on how you're configured, how you get through your compliance. The modules are clearly there. They cover those particular areas. But they do have a lot of commonality associated with them. They all ask for a good product description. Design and manufacturing drawings, schematics, and explanations. Well, whoopee-doo. We got to put our schematics together, just like we do for FCC or pretty much anything. The drawings and et cetera need to be there, explaining how this circuit gets to where it's at. So if you've got this kind of program established, it's within your documentation, you refer to that in your risk analysis instead of redoing all of the particular elements. So don't sit here and make this more difficult than it needs to be. If you've got the explanations and they're very clear and they point to the appropriate documents, then you just need to indicate that that's covered in that area. You may want to put a short burst about it so it's not obscurely done. Believe me, I've evaluated risk papers. They can get very obscure. See drawing X, and you look at drawing X, it's got everything on it, and you don't know what element they were talking about to cover that particular area. So the explanations need to point to the detailed area covering that particular requirement. The list of applied harmonized standards. Remember that the solutions applied, if partially applied to the harmonized standards. If you're using a harmonized standard and didn't do it completely, in other words, you omitted a section because you went off on something else because of your unique requirement, you need to take care of that solution area. The design calculations, the examination, in other words, your test reports, okay? It's there. What did I do to get there, and did the test cover it? What examinations did I have them do, or did I do? Did I supplement the test report to make sure that what I have put in, I may need to have a very tightly controlled variance on a particular component. So we need to look at this element. We had a customer go crazy during the temperature evaluation because he changed frequencies at a sudden point. And it was nothing more than the crystal issue, and it was in the temperature range of it popping. The manufacturing, the processes, and monitoring to ensure compliance with the technical documentation. If you have critical functions within your device or critical features to make sure that you are compliant and you use that, those drawings and explanations, etc., to do that, and the manufacturing fails to implement that, then you've got a problem going on. So you need to deal with that as part of this commonality thing. What are you doing to make it go there? Can the manufacturing change the process without engineering approval regarding how this design is compliant? Do you have a compliance person on your change notice approvals? And remember, markings and declarations are always a part of this, so you need to get your labels correct, and it covers this. You need declaration of conformity. And there's a lot of more information contained in these modules and submodules. I can go on till next week about that particular subject, but you're going to look up the things that apply to you and apply them appropriately. What standards do apply? Well, the standards are normally linked to an application. Information technology, industrial, scientific, and measurement, medical, machine. Several things are there with commonality between these standards, but there are distinct differences. Normally, conflicts are not present. I'm not saying that it can't be, but normally they're not. The IEC standards are frequently adopted by the NCBs, or national certification bodies, and incorporate their national differences and result in the release of an EN or a UL or some standard based on the IEC. Now, this may or may not be a radio specific. Remember, there are also horizontal standards, those things that have the same scrutiny that they're done additionally to the complete general standards, and vertical standards normally are often referred to as the particulars. So if I have a vertical standard, it may become dominant over the general standard. So you have to look at the conflicts are resolved by having a priority system. Remember, the vertical standard takes precedence over the horizontal or the general standards. And horizontal standards have the same precedence as the general standard. For EMC, generally with the radios, 301, 489-1, and other verticals, a -3, a -17, a dash whatever, regarding your particular requirement. So that would become dominant over that. The safety standards are not specified. So which standard do we use? And remember, I referred to 62368 a little bit earlier, dealing with information technology equipment. A lot of people think the communications of the radio is in fact what drives this standard, and that is an information exchange, whether it be data between sensors or not. That shouldn't be what we do. You should select the standard without the radio, and you apply that. For instance, a medical device, if you remove the radio, then the safety for medical would be applicable. With the radio, it still should be medical, not an IT equipment. Medical shouldn't be able to change just because we put a low power sensor or a radio or a wireless connection in it. So remember, we're evaluating for safety based on the product as if there was no radio, and then we can't omit the radio kind of evaluations. So select your standard appropriately. Disassociated standards come about, quite frankly. Product application normally defines a standard. So if I'm measuring something, a safety standard of 61010 would be what's applicable. but product integration sometimes do other options. IT equipment may go into an item so we can display and control measurement devices. So does the measurement happen, or does the IT equipment happen? For instance, that computer or laptop or whatever. Well, most of these safety standards allow integration of these kinds of elements and say that's an acceptable standard for use for that component area. If you've already got an approved computer that you just set on the shelf there and make a wiring connection to your measurement device, then the IT standard would be accepted there. Other standards are not so fast. A standard, an IT equipment placed on a medical device may not meet the isolation to a patient. So we have to consider what it is and what's acceptable is there. If we can maintain total isolation, it's operator only, the IT approval may be okay to deal with. So dealing with this, sometimes machines can be appliances. It's hard to tell a difference sometimes. Or we integrate measuring equipment into the machine so it can operate properly. The evaluations for a disassociated standard may limit the use in the intended application. So if I evaluate a measurement device as part of a machine, then selling it as a measurement device may be very restricted. You may not have enough information to support your declaration of conformity as a measurement device. So standards are there. Let's get into this essential requirements kind of mode. The Directive section Article 2, I think, discusses these essential requirements. Health and safety takes on a high precedence, and adequate electromagnetic compatibility. Adequate means just what it says. I may not be totally immune, but I have an adequate immunity or an adequate emissions level. It says meeting these requirements, it's an acceptable condition. Obviously, if it causes harmful interference, you got to deal with it. So just because you applied it and passed doesn't mean it's all said and done. Especially if I've got a medical device that I put in the electromagnetic compatibility and it affects the radio performance or the medical requirement, it's not going to be acceptable. It needs to have effective use and support efficient use of radio spectrum to avoid harmful interference. Interference which endangers the functioning of radio navigation or other safety devices, safety services, or seriously degrades, obstructs, or repeatedly interrupts radio communication services operating in accordance with the regulations. So if I interfere with the operation of a licensed device or something else allowed to be operating and it meets the regulations as far as immunity as well as emissions, then if I affect it, then I'm causing the harm of interference and must stop operation. I can't interfere. I'm not allowed to do that. The devices are dealt with in that kind of a manner. We also have certain categories of requirements that come into being. I particularly enjoyed this one. Common chargers was one of the essential requirements. And that is indicative to taking care of the WE program, the Waste and Electronic Components. This radio directive says you can't put a charger on that is unique to your device or proprietary. So a charger must go with your unit and not have, for no other reason than to be sell your own devices. So like a mini USB adapter might be something you'd use, and if you're going to use something that will support, then you're obligated not to create a proprietary. Keep this excess charging equipment away. Where the device may get an upgrade, the charger is going to be good for a long term, and it avoids a lot of waste. So that's in the directive for certain categories of equipment, and it affects a lot of the world here of having these things, because we have all dealt with electronic equipment and we go in and have proprietary chargers. It's got to have a cup to set it in. It's got to be worn on your wrist with this behind it. It's got several things, a waterproof. And we must support interworks with via networks with other radio equipment. It's got to work. It's got to deal with other things on the radio link that may be there and be compatible with the exchange of information. Connection interfaces of the appropriate type. I can't put my proprietary on it without connecting to something that's already there. Prevent network harm. Prevent personal data and protect personal data and privacy. Whoa. So a radio link that is dealing with a banking area might have software requirements to protect the data, not let that be transmitted via some mechanisms. Protection from fraud, so you can't get into it very easily. Ensure access to emergency services. If you're sharing a channel where emergency services might be there, you must be able to detect and be quiet during that event. Facilitate the use by users with disabilities. Some standards require that the wireless device meet certain requirements, like the radio communications compatible with hearing aids and things like that may come into being as those kinds of things. And restrict software not approved for a particular radio. Software may be defining the radio performance, restricting the bands and controlling channels and hopping and etc. And you cannot allow software to be loaded that is not approved. So you need to restrict people from being able to override the existing software to, quote, tune up their radio and make it more effective. Higher transmission levels. So let's kind of look at a few things here to as examples go on. The RF applied power. That is a potential harmful effect and the harmful interference if I allow too much power. And your essential thing might be meant to say you comply with the, quote, appropriate standard, whatever that is. The duty cycle, transmit sequencing, transmit gaps, etc. Again, another standard. Unlimited emissions, spurious emissions, receiver spurious emissions. And this is just taking a few extreme environments, controlling the temperature exchanges, humidity, etc. How about voltage? Depending on the applied voltage I provide to this, I may have to get a voltage regulator that prevents an overvoltage driving more power or whatever's associated. This common charger thing, it says the use of a common charger is one of the elements' essential requirements. You may be able to say you're unable to meet the goal of having this particular charger because your device has an unusual power requirement that's not compatible with that. It doesn't support the current. So you may have to put in something specific to manage the current. Well, can I get another common one that will support the current? Possibly. So the commonality may be there, and justifying that you're unable to meet the requirement because if you have a justification that's adequate, your charger may be exempted from this common charger limitation. So you deal with it under the risks. I've got too big a risk of fire or damage or inadequate operation, failure to function, failure to charge, etc. Rationalization must be presented to support it. So it's part of your risk analysis. For EMC, I may need to deal with radiated and conducting emissions using a particular standard, 301-489-1 and -X, they're kind of there. Also dealing with the radiated conducting immunity. I may want to break it down even further to deal with ESD, surges, etc. All of the various elements that I need to cope with. Did I take care of this? And especially if I need to explain how I control it. For surge, I may have put a transient voltage suppressor in place. So my item might be how did I solve the problem? And by the way, this doesn't look like the first one you saw. It's kind of an option because this is not defined. These are just how I chose to present it today. So the idea is that we can do this through words, tables, charts, good analysis points, an explanation that takes on a white paper format. So lots of things go into the elements, and how deep do you want to go? How deep is your reviewer going to ask you to go? How deep should you go? That's a function that you're going to have to decide based on your elements. For safety, I might want to risk electrical shock issues, mechanical hazards, fire hazards, thermal hazards, etc. And I dealt with under the various standards that are appropriate for that. Big radiated exposure, laser, I may call it the laser approval kind of function. Chemical hazards, what did I evaluate that to? Did I control it? And etc. Lots of various things. I may need to deal with safety as part of radiation for RF exposure, where I have an MPE for mobile devices, and I may have a SAR requirement for portable devices. So how did I work this particular issue? There's lots of definitions there. I feel that this is appropriate for what we're working with. It allows some flexibility in how we cope with it, and your notified bodies are going to ask you to be clear about it. They're going to drive what they're asking for because they're going to look at it very thoroughly. I know that some of the bodies look at this, make sure the laboratory did an extreme temperature thing, that they covered the range for all of the various tests where that is required. It may not be just one test. It may be that when I put this thing into the extreme temperature range, how many tests have to be done for that applicable standard. So we got to pay attention to that, and your risk analysis needs to consider that I've covered all of the tests in the laboratory. That in the laboratory has been communicated, and you reviewed that is in fact covered. So putting this risk analysis in enough detail in front of the laboratory sometimes makes sure they evaluate more thoroughly than you might expect, and document more thoroughly if you place that requirement for them to provide you that documentation. Your product may introduce elements that are not contained within the standards or the directive. You need to work with that, somehow make it part of your process. You're advancing the technology. The risk you identified is not covered by the standards that are applicable to this. Do we need to incorporate different things? Notice that the red introduction has incorporated receiver evaluation elements in the compliance standards. So it's not just a transmitter anymore into this, as the receiver is a clear part of it and how adaptable it is to the environment. You need to look at these essential requirements, particularly in the certain categories for applicability, and include that in your analysis. Don't omit this essential requirements if they exist. If you have a need to meet a disability requirement, you need to cover that as part of your risk. I have to do this, so therefore I've done these measures to take care of that, and I'm going to evaluate them through my own explanations and evaluations that, yes, this will in fact adapt to a hearing aid piece, and the testing may not be part of your radio evaluation, but it could be a partial test based on your own laboratory event. That adaptability may not appear in the standards very readily, but you might have to deal with this. And the test is just one of these ways to demonstrate the compliance. And it's a typical method. A lot of the standards, you just simply do the test and evaluation. I met the requirements. I have, in fact, the risk is now an acceptable level because the standards have been met. So don't hesitate to think that way. Your file needs to include these risk analysis, addressing the health and safety, electromagnetic compatibility, and the efficient use of spectrum. So your file needs to take care of that through your risk analysis. Your notified body is going to require this thing. And if you do a self-declaration because you went with a harmonized approach, well, your file still needs to deal with it. Did I deal with this thing to the harmonized? Did all of my risks get addressed by applying the harmonized standards, or were omissions present? Provide for sample testing. You do have a requirement in the risk requirements to sample at some basis to say that production does still meet what you do this. And you also need for market removal. If you're shown to produce harmful interference, you're obligated to remove it from the market. Take it away, recall it, shut it down, do whatever you need to do, put in fixes, do things like that. Your representative in the EEA, the European Economic Area, needs to have the ability to do that. Where did he sell them? Where are these devices present? Can I recall them? So the idea is record keeping is kind of a key element. Your file needs to contain all this information. You need to look at complaints and things like that coming back about interference. Did you actually evaluate it and prove that you were or were not interfering? And if you proved you were, what have you done to solve it? Lots of good websites for things there. We have a lot of information on our website, and obviously you can contact me or any of our technical personnel regarding the wireless device evaluations, what's appropriate. Steve Koster, our president, Steve K at WLL.com, is very versed in this particular subject, and he loves to speak with people, so don't hesitate to reach out to him also. And I guess I'll open the floor up for questions, Christina. I burned out here.
Okay. Looks like we have a few questions. First one, if risk analysis doesn't support acceptance of risk, why do we use this process instead of just testing per the standard?
I think it's dealt with in a risk-based system to advance technology. We're incorporating things to support disabilities. We're incorporating things to support We're doing this thing, and we're also advancing the capabilities more rapidly. Think of what our lifetime has seen over the past 10 years in cell phone use and the various radios within a cell phone and the compatibility, etc. So the standards, being able to keep up with that would be extremely difficult because the market life on a device like that is, 90 days to 6 months max. So 3 months after you have a technology, you're releasing the newer technology because a large percentage of sales has already happened. And all of these devices and the explosion that we're seeing today in modulation techniques, you name it, to take care of the massive amounts of wireless devices that the Internet of Things is bringing forth on a routine basis. And it's going to get much bigger. It's going to triple or quadruple in size over the next 3 years. So we have to maintain this. The spectrum is limited. The channel size is limited. So if we can somehow fit a 100 megahertz channel into a 10 kilohertz bandwidth, that would be a wonderful thing to happen. And it would get adopted because it frees spectrum. It allows more of these devices to be able to operate. Shared systems, things like that, software, what are we doing? Because the creativity is going on daily. So I think it's driving these risk analysis issues that we have to look at it. Well, if we do this, what can go wrong? And before we get 50,000 units out in the marketplace or out in use, and suddenly they say, the airplanes can't fly within 100 miles of us because of interference, that's not acceptable. We lived that in the 60s. We don't need to do that again. So we have to pay attention to this, look at the risk, evaluate it, and make control measures happen and become effective. It's no longer, I may bother somebody, but it's not likely. That's not an acceptable condition anymore because the likelihood will come to get us. So I think risk-driven evaluations are our future. I don't think it's going away, and we have to pay attention to this. Sure, we can't quantify it and say, okay, that's acceptable, because we need to mitigate the issue. But unless we identify what the issue may be, we will typically not take action to mitigate it. And it's hard to justify that in releasing a design and putting it on the market that just drives everybody insane. So needless to say, I think risk is happening, and it's going to be happening, and it's appropriate.
Okay. So, Steve, if a device has multiple radios, can conflicting requirements be resolved by risk analysis?
I would hope that we don't have conflicting requirements, especially on the multi things where, you've got 4 transmitters in the same box, and it's a very small box or more. And they each have requirements because they do different functions, and they have their own standards, and especially vertical standards. I think that the standards deal with risk. I think that the standards consider conflicts in dealing with this situation. So if they don't, then the risk has to, quote, address it, but it may not be resolved. So it may press us into a notified body must get involved to provide an approval and direction that the standards committee must adopt and resolve the conflict if that technology has pressed forward. I think that's where it's driven more than anything else, is the technology just didn't consider that those two things would be together ever. And so the conflict, I don't see them. Does whoever wrote that, if they got a specific question or whatever, just write to me. I'll get an appropriate person. It may not be me, but I'll get an appropriate person to look at that of identified conflict and see how it should be managed and provide that information back to the person that asked. I'm sure I can't get to it in today's discussion. Okay?
Okay. We have actually a pointed question from the EU side. The main issue at the moment in the EU is how to perform at risk of non-compliances, reference decision 768. The manufacturer has to argue why every essential requirement is covered, even if a harmonized standard is applied. Do you have an example of how this risk of non-compliances can look?
I think that the kind of tabular thing I did is dealing with it. I want to back up to one I think it may be helpful for that question. Right here, where I have the common charger, I place a generic, very short thing of the unable to meet the goal of the mini USB goal because the power demands exceed the pin capacity. That discussion would need to be expanded. And if it says, okay, here's a certain requirement that we're not going to meet the goal of having, with these kind of devices, the goal may be to use mini USB chargers, and I've got some integrated function within my device that's a power hog and just can't deal with it, I can simply say, well, it's non-compliant with that certain requirement, and here's why, and I believe that should be acceptable. If your argument is sound, has a good basis, and you show enough evaluation of alternatives to say that your unique charging system needs to be applied here, you need to make that convincing case to the notified body so you can get the approval. It's not saying you can't do it. It says it promotes the use of. I think it's the words promote. But if you need to be able to get your function down pat, and if you're making a case for that and it's appropriate, you may not be able to make your device do the right things without having enough power capable to make it operate while it's into a recharge mode. So I may be able to cope with those things. I don't have a specific example myself, but that may have answered that particular thing as a, quote, sample example. Obviously, the expansion of detail would be required. If you're trying to make a very short table on how you do it, that one area may be referring to section 6.4 for the detailed explanation of why you have to use what you do. You may declare it is subject to approval instead of does not meet the requirement. It's an indicator that, yeah, it's subject to approval. We're waiting on a response, and we believe it's going to come out versus, hey, this thing fails, accept it anyway. I don't think that's going to get a lot of use, but your positive approach is that this is pending approval. And once the approval happens, you update your risk analysis to show the approval. This deviation from certain standard was approved by yada yada, whatever. And that covers you until the standard update happens. I hope that explained enough. Okay?
Well, yeah, that individual wrote back and said that it's a mapping for each essential requirement is required as to why that ER is closed. He says that's not it. But anyway, I think perhaps you could have a little bit of correspondence with this individual?
Sure. SteveF@WLL.com. I'll try to take it offline.
Exactly.
Okay.
Let's see. Well, I got a couple more questions. So let's see. Your examples involved risk by using tests to evaluate the risk element. Is this always the case?
No, not really. Some things are there based on drawing review or examination, like did the good example, I don't know, the work with a hearing aid. Did that, because all hearing aids are not created equally, but the hearing aid requirements may be looked at as to fit and compatibility with devices, and the type of earpiece necessary to prevent feedback and streaming and things like that may be covered in that standard. And you evaluated that the form of your earpiece met that requirement through a physical examination, that you did not overdrive the sound levels. Sound levels may not be something that's evaluated during a radio test, other than the fact that it functioned. But having to deal with sound level control for that certain requirement could be dealt with outside the test arena, I would think. Other things could be dealt with outside the test arena. So I don't believe that it's restricted to that. The analysis could point to a analysis or examination or a form fit function drawing and describe how that applies and meets the requirement. It may be adequate for particular requirements. Okay.
All right. So how does a new manufacturer with no prior knowledge of wireless assessment jump into a risk assessment with no guidance from the directive? Specifically, manufacturers are only being told what they're doing wrong, not how to address the risk. What advice do you have for these manufacturers?
Get help. There's lots of people that specialize in this kind of work that are available through a service contract. You can read until you're blue in the face and come up with, what did I just read? This is a complex situation. A new manufacturer delving into this, or suddenly they need to incorporate wireless into their unit. They should consider buying some service time from consultants that specialize in that area, especially to get their program initiated. It's not embarrassing that we don't have that knowledge. It's just a complex thing depending on your marketplace. What goes for Europe may not go for the U.S., and they are not always compatible. What frequencies are allowed to operate in this country at what power levels? Those things require a lot of research, and figuring out what the accurate answer is less than easy, shall we say. I looked at a news story last night regarding the pythons are overcoming the Everglades in Florida. And there was a news story where they had been hiring professional snake hunters and paying a bounty on the boa constrictors because they don't have a real threat within that area. They tend to kill alligators and things like that, so they don't necessarily have a good threat to take them out. And what they're doing is eradicating the population because they eat the small game that are defenseless. So the idea is that there's a risk associated, in getting professional guidance is the appropriate answer. That Florida Game Commission tried paying a bounty to amateurs and got nowhere. It didn't help a bit. They hired professionals that know where to go, and et cetera, and provided enough incentive to go after them. So they're getting a reduction to happen. So the idea of this, get the professional to guide you into selecting the appropriate radio module. Is a modular device suitable for you? Do you need to develop your own? Do I have to do a permissive change to integrate it? Do I have to file these papers? My radio device is now just a simple, I put somebody else's radio within my box. And did my box make changes that require reevaluation, or is it acceptable as is? So the professional guidance is where you're looking at. There are several people associated that provide guidance. we're available to do that kind of thing, and most any laboratory accredited for radio work may be able to do this so long as they have a mechanism of isolation. So the test lab can't tell you how to design it and then evaluate it. So that's a conflict of interest. So getting the test lab to provide you with a recommendation or identify somebody or just simple search for those things is not too hard to do. EMC consultants or wireless radio consultants is a good Google search topic that results in probably more hits than you can imagine. Now, finding a good one, that may be a more difficult task. That's where your lab may be able to say, oh yeah, I know him, or I can investigate or something for you to say that he knows what he's talking about or knows what he's doing. So it's there, and I think it should be used by people jumping into this to avoid a I don't know what to do mode, and they get locked up, or they go to the lab and they get that, oh, it fails, you don't have this, and they don't get any guidance on how to fix it. That's not the right time to find it out. Get the guidance ahead of time. Go in with your risk reviews, that your channel size filters are working, your NASCA compliance takes care of that, and your design has these incorporated within them. And it's adjustable over the frequency range and stable and yada, whatever. So get somebody there if you're new and don't have a wireless professional in that. If you do this a lot, your wireless professional should be somebody you have on staff. Because if you're incorporating one thing and that's the only thing, a contractor may be able to take care of you and establish programs so that you continue it. But to get going, get somebody to help. Okay.
There you go. Okay, I think we have time for just one more. Is risk analysis applicable to non-EU compliance for radio equipment?
Well, the Radio Equipment Directive comes out, and it talks about these risks and documentation, etc. The idea is that this risk is a EU-driven directive. It doesn't say that the risks aren't present for other devices. However, they may not be a required file element. I can't answer that to every country. Some, and a lot of countries, follow the IEC or the equivalent EU, or they accept the EU evaluations for their applications if the frequencies are permitted. So the idea is that you may get a long way by going ahead and doing it. Number two is that if you got this with you, you're not restricted from using it for the applications on various countries, where it may not be required, but it may be get you over a hurdle. It's not a bad philosophy of going there because it says you have a good understanding and you have mechanisms to take care of it. You're self-evaluating. It may not be as formal as something you submit, but why not make it formal? Make it part of your file so you know your basis. And so the next person that comes in, when you went on to greener pastures or decided I'm tired of this and buy a septic truck, and the idea is that the information is there for them to know how you got where you got. Okay.
Okay, great. Thanks, Steve. I believe all of the participant questions have been answered. So quickly before we go, I'm going to go over some information about upcoming training. Of course, you can link to us at wll.com/us/academy and find information on all of our webinars and resident courses. Here is what's coming up. Last week's product safety webinar completed that series, and today's session completes our wireless technology webinar series. So in case you've missed any of our previous classes, recordings are always available. June the 6th is a 3D PCB design and integration course at our Gaithersburg, Maryland location with expert Robert Hansen. Includes an opportunity to sign up for your specific product design review. The environmental webinar series is going to start June 20th. It's going to run each Tuesday through August the 1st at 11 a.m. on Tuesdays. Battery technology. Oh, I'm sorry, go ahead.
We omitted the July 4th weekend for that webinar. So a lot of people are vacationing. We decided not to try to hold it that week.
That's right. So every Tuesday except for July 3rd. That'll work. Battery Technology by Battery University. We have a 4-part webinar series running again. We had it run earlier in the year, and there were a lot of people, a lot of clamoring to have more of it, so we're going to run it again in September. And then in Washington,
the Robert Hansen course, I want to point out that that's coming up next week, starting the 6th, I believe. Is that Monday, or that starts at Tuesday anyway?
Yep.
That week, and it's 3 days, plus he's got a 4th day allocated, so you can bring in your design and review it with him. There's still a couple of seats available for this particular thing, so if anybody's interested, you may want to jump all over that. Registration should be hitting this week in order to get you in.
Right. So that's everything for the lab for the next couple of months. And then, of course, in D.C., we have the IEEE EMC Signal and Power Integrity Symposium on August the 7th. And I know, Steve, you say you'll be there.
I'll be all over that place. I'm on the committee this year, as well as have two tutorials. And I've got some obligated time in the IEEE booth exhibit area for me to talk to people in to a couple of booths. So we'll be busy. And then, obviously, the Washington Labs booth is going to be there, and I'll have to spend some time there. So I'll be around. Please, if you're there, say hello to me. I enjoy meeting people that I may not have met because of this particular media.
Okay, so all of our webinars, recordings, and resident courses are available for purchase from our website. They're available as multi-part series events. You can pick each little class, join in on the discussions. You can sign up for the whole series and receive a 15% discount. We'd like to hear from you with suggestions on future topics that we can present. We also provide customized training at your place or ours. I don't see any other questions, Steve. I think we're going to go ahead and conclude today's webinar. So on behalf of myself and Washington Labs Academy, I'd like to thank everyone for their attendance and enjoy the rest of your day. Bye-bye, everybody.